Right, so I just explained shifting and scaling and reflecting. So we are going to do something similar, uh, but this time we're going to do it with a different function. Let's look at x squared. So if I look at x squared, if I were to instead, I'm going to get another copy of this and then I'm going to hide that one temporarily. If I were to get in here and say subtract 4 from x, then what should happen? Take a second and think about that. What should happen? Well, it should, because I've subtracted from x, that should shift it horizontally, which is the x direction. And it always shifts the opposite amount by what you added. So since it's negative 4, subtracted 4, it's actually going to shift 4 by positive 4, which is in the right direction. So it should shift to the right by 4. Hey, there we go. Shifted it to the right by 4. So now let's take that, and next let's talk about let's put like a 1/2 in front over here. Okay, so that means I'm taking the function that I had before, and I'm now multiplying it by 1/2. So what this is, take a minute and think about what transformation is going to occur because of that. Well, you could have thought of this instead of multiplying by 1/2 on this side, it could have been multiplying by 2 on that side. So multiplying y by 2 should actually have the effect of scaling in the y direction by the reciprocal of that number, which is going to be 1/2. So having a 1/2 over here actually means we should scale it by 1/2. That means it's going to be cut in half. The y coordinates would all be cut in half. It's kind of hard to tell. Let's kind of compare it to the original. There was the original. It has the point, for example, 2, 4. When I multiply it by 1/2, that should become 2, 2. Let's double check if that works. Oh, we have the point, looks like we have the point 2, 2 right there. So there it is. This is on top of our shifting to the right. We also have scaling vertically by 1/2. So cutting all the y's in half. Then let's say instead of positive 1/2, this is actually negative 1/2. What is the impact of that? See if you can guess what that's going to be. Should be, let's see, negative is outside of the parentheses, right? We have the parentheses here. So this is as if we had done the negative on the left side to the y, except we moved it over. So that means it should be changing all the y values to be negative instead of positive, which should reflect it over the x-axis. Hey, there we go. Good. And then the last thing I want to do is, let's see, add 2. So what does it mean to add 2? Well, it's on the outside of the parentheses again. So it's not inside the function, it's outside the function. So we should be shifting, because it's addition, vertically, either up or down. Since we added, it's going to shift down, right? Oh, no, it shifts up. Why did it do that? Well, remember how subtracting from x makes you shift to the right? If you add to x, it makes you shift to the left, right? So it always does the opposite, except here, if you move this to the other side of the equation, instead of adding 2 on the right side, it would have been subtracting 2 on the left side. And when you subtract 2 from y, just like with x, it moves actually in the positive direction instead of the negative direction, which is the same exact idea, except vertical instead of horizontal. So it behaves exactly like you expected. It's just that we move it over to the right side, put it outside the parentheses because you're adding to the whole function, and you end up shifting it up. So this is the graph of this function. So this is combining, let's see, 1, 2, 3, 4 different transformations together. One thing.